Hi, welcome back to the chapter on complex number. Today we will be attempting two questions. Question 1. Let Z be a complex number satisfying this condition. Prove that modulus of Z minus 9 over 8 is equals to 3 over 8. Now let me copy this down. So you have modulus of Z is equals to 3 modulus of Z minus 1. Now we can put the 3 inside, so modulus of Z will be equals to modulus of 3Z minus 3. Now we want to prove this. Perhaps we can just expand a bit, alright, then from there we can see what should we do to this equation. So I write over here, so you have modulus of Z minus 9 over 8. Now what is this? This will be equals to Z minus 9 over 8. Alright, I square this, square this will be equals to this times the conjugate of this. Okay, this squared will be equals to this times the conjugate of this. But what is the conjugate of this? That will be conjugate of Z minus 9 over 8. Okay, maybe I just multiply them out. So I have Z conjugate times into conjugate Z minus 9 over 8 Z minus 9 over 8 conjugate of Z. Then right over here I have plus 81 over 64. Now back to this. Perhaps what I can do is I square both sides. Now if I square both sides, what will I get? I will have Z into, maybe I just write it here, into Z conjugate will be equals to 3Z minus 3 into the conjugate of this. But the conjugate of this is just 3 conjugate Z minus 3. Okay. Now, maybe I just expand it out. So that will be equals to 9Z Z conjugate minus 9Z minus 9 conjugate Z plus 9. Okay, now I bring this, I minus Z into Z conjugate on both sides. So I have 8Z into Z conjugate minus 9Z minus 9 conjugate Z plus 9 equals to 0. Okay? Now, look at this. It is rather close already. Alright? So what I do, I divide by 8 on left and right. So I have Z conjugate minus 9 over 8 Z. Then I have minus 9 over 8 conjugate Z plus 9 over 8 equals to 0. Now, so I plus 81 over 64 on this, on both sides of the equation. So I have Z into Z conjugate minus 9 over 8Z minus 9 over 8 conjugate Z plus 81 over 64 plus 9 over 8, 81 over equals to 81 over 64. So this part already is exactly the same already. So this whole part will be here. All right. So I minus 9 over 8 on the left and right. Now what is this equals to? This is 72 over 64. Okay. So this minus this, I get 9 over 64. Now, so from here, you know what is this equals to? This is equals to this. All right, this times this, okay? And which is equals to z minus 9 over 8 modulus square. Okay, maybe I just write this first. This is equals to z minus 9 over 8 into conjugate of z minus 9 over 8. All right, equals to 9 over 64. Now this can be rewritten as modulus of z minus 9 over 8 whole thing squared, all right, equals to 9 over 64. Now if I square root both sides, all right, I will have, now so implies z minus 9, modulus of z minus 9 will be equals to 3 over 8. All right, not plus minus 3 over 8, because modulus of something is always positive. Let's move on to question 2. Next number. Question 2. Now let the modulus of this complex number be equals to 1, and modulus of z2 is not equals to 1, where z1 and z2 are complex numbers. Show that modulus of z1 is equals to 2. Now, you realize that actually this comprises of two complex numbers. One complex number is the numerator and the other complex number is the denominator. All right, so what we can do is we can separate it out. So you have modulus of conjugate z1 minus 2 conjugate of z2 over the modulus of 2 minus z1 conjugate z2, the modulus of it, and is equals to 1. Now I can do a cross multiply, all right? So implies modulus of conjugate z1 minus 2 times conjugate z2 will be equals to the modulus of 2 minus z1 into conjugate z2. Now you notice that this complex, the modulus of this complex number will be equals to the modulus of this complex number, which means that the modulus squared of this will also be equals to the modulus squared of this complex number. Now, the modulus squared of this will be equals to the complex number z1 minus 2 in 2 times the complex conjugate z2. Now, this will be equals to this times the conjugate of this. All right, that will be conjugate of z1, conjugate of conjugate z1 is z1 minus 2, conjugate of conjugate z2 is z2. Now what is this? Same thing, here will be 2 minus z1 times conjugate Z2 will be equals to, no, this one you need to multiply by its conjugate, then you get the modulus squared, all right? So the conjugate of this is what? So this you get 2 minus conjugate Z1 and modulus, complex number Z2. Now let's multiply this thing out. So you have conjugate Z1. All right, I put Z1 in front, then the conjugate behind. Then I will always put complex number Z1 in front of complex number Z2. So it's easier for us to compare. So this multiplied by this, I have minus 2 modulus Z1 into conjugate Z1 into Z2. Then this multiplied by this, I have 2 Z1 conjugate Z2 plus 4 conjugate Z2 into Z2. This times this is 4. This times this is minus 2 conjugate Z1 into Z2. Then this time this is minus 2 conjugate, now 2Z1 conjugate Z2. This multiplied by this, I have plus Z1 conjugate Z1, Z2 and conjugate Z2. Okay? Now, if you look at it, then you will realize that these two terms are like terms, and these two are like terms, and they happen to, they can cancel out each other. So this cancel out with this, and this cancel out with this, since their signs are the same. So everything I just bring over. Okay. Now, here I have Z1 and Z1. So maybe I just bring it over. Now then I have Z1 conjugate Z1. Now I bring this term over, minus Z1 conjugate Z1, Z2 conjugate Z2. Now why I bring this over? Because I can see these two terms are the same, all right, Z1 and conjugate Z1. So maybe I can factorize them out later, and hopefully we can arrive at something. Then you have plus 4 conjugate Z2 and Z2, and this 4 I bring it over, so I will have minus 4, then is equals to 0. Now Z1 and conjugate Z1, I can bring it out. But what is this? This is actually Z1 conjugate Z1 is modulus of Z1 square. All right. So here I have 1 minus. Then Z2 conjugate Z2 is a remaining term. All right. So this will be modulus of Z2 whole thing squared. Okay. Now 4 is common here, so I can take 4 out. If I take 4 out, here we'll have Z2 times conjugate Z2. That is modulus of Z2 squared minus 1 equals to 0. Okay. Look at this. They are exactly the same except the sign. So I change this to minus. Okay. Now, so I change this to minus. The sign here will change. Then after that, these two terms are similar terms, all right, or identical. So if I factorize, here will be Z1 square minus 4 close bracket into 1 minus modulus of Z2 whole thing squared equals to 0. Now we are given that this is not equals to 1. Modulus of Z2 is not equals to 1. If modulus of z2 is not equals to 1, then modulus of z2 squared will not be equals to 1. So this whole thing will not be equals to 0. Alright, this one does not equals to 0. Why? Because modulus of z2 is not equals to 1, given. Alright, so you are left with this. This has to be 0. Now, so implies modulus of z1 whole thing squared minus 4 is equals to 0. So I bring it over. So modulus of z1 squared is equals to 4. Alright, therefore modulus of z1 is equals to 2. Now do a square root, you should have plus minus 2, but because you are doing a mod, so it will not be negative. Alright, so we have come to the end of the proof. Now we will always be producing videos so that you all can learn anywhere and at any time. So please keep on the lookout, and if you like our channel, please press the subscribe button. Thank you for watching and have a nice day.